When you come in on Monday, I'm getting the new carpet put in tomorrow. In the morning, I'm going to get here early, set my room back up, but I don't care about the order of my desks. So if you notice, all the desks have a number and a calculator that matches that number. Please keep it like that. If you come in and your calculator isn't here, you need to tell me that I know the person before didn't. Can you wait just a second? So listen. If your calculator isn't working, let me know. Okay, don't just grab another calculator. It becomes a domino effect. Usually it's just calculator battery issues. Okay. Having said that, when you come in on Monday, if he wants this seat, that's fine. He can sit here. It just might not be number 25. Is all I'm saying. So when you come in on Monday, actually that's not really that important for this class, the numbers. But when you guys come in on Monday, find the seat that makes you happy and sit there, and I'm going to make a seating chart according to that. So if you know you need to sit towards the front, if you know your eyesight or whatever, or after I'm done today, if you're like, I had a hard time at that angle seeing one of these screens, then just make a smart decision on Monday and move. If we have a reoccurring issue where people are talking while I'm teaching, I can't stand that, guys. That's just so disrespectful. So if that's a problem, then I will move you. But I want you to first give you the benefit of the doubt, just like I am with the phones. Shouldn't have your phones out while I'm talking and teaching, and you shouldn't be talking while I'm up here teaching, okay? And so if either of those things become a problem, I will address them the way I need to. But in the beginning, I'm going to let you sit where you want and trust you to have your phones put away while I'm teaching. Yes, sir? Well, I don't want you to rip now because I'm going to get started, but it will be 5 to 62. Okay, I know it sounds like a lot. Don't stress about that. As I said, a lot of those pages we won't use. I'll be supplementing. But it's easier than me saying 5 through 8, then 12 and 13. Just rip those out, put them in. We'll use some, we won't use some. Okay, I know it seems a little confusing right now. We'll get it, I promise. Okay, I really am very organized and stuff like that. All right, so there's a lot on these pages. I'm going to be writing on them and kind of highlighting certain things that are important, and I'm going to ignore things that are not important. In fact, I might even cross things out. But if I address it, that's something that's important, and you'd probably want to write it on yours. I don't care what you write with. I use lots of colors. You use whatever makes you happy, okay? But these are your notes starting now, okay? When I'm done with the notes, then I'll tell you the homework assignment, and you can work on it for the rest of the class, all right? All right, so first of all, we're going to back over some really basic vocabulary, and you might remember these, you might not. First one is a relation. So a lot of times I use like the spaces that I can on the paper. A relation is just a set of ordered pairs, okay? So when I talk about a relation, I just mean a set of ordered pairs, you know, like X's and Y's. And relations come in all different forms. A graph. A graph is a relation because that's just a visual representation of a bunch of points. An equation, y equals mx plus b, that's a relation. If you graph that, it's a bunch of points that connect and happen to make a line. There's mapping diagrams, you know, like the bubbles where arrows go back and forth, that's a relation. So that's all it is. Then we will be asked, is the relation a function? The word function is a relation, so a set of ordered pairs, with no repeat. Does anybody know what I'm going to say here? No repeat what? X values. Okay, and I'll show you examples of these in just a second. We also have something called the vertical line test. Okay? So just some vocab words there for you to be familiar with that we're going to address down here in this section. So I'll explain those better with examples. Yes? Okay. I really prefer you guys not to go to the restroom while I'm doing notes, but, you know, like I said, you guys will go. All right. So functions, this definition I was just talking about. I'm just going to read. A function describes a relationship between input and output. Guys, input are your X values, outputs are your Y's. X and Y. It's alphabetical too. X comes before Y in the alphabet. I comes before O in the alphabet, if you ever forget. The domain is another way of saying input or X values. Domain, X values, and the range are the y values. I'm kind of highlighting some things for you in the paragraph there. So we have three different ways of naming these parts of a relation. So a relation is like a bunch of ordered pairs, x and y's. The x's are called inputs or domains. Y's are outputs or range. Again, all alphabetical order. X comes before Y, I comes before O, and D comes before R, domain and range. I am one of those people that has a hard time memorizing things. I just don't have good memory recall, so I need little tricks for everything. So I try to pass those on whether you need them or not. Okay, so you get confused which one is which, alphabetical order. X, Y, I, O, D, R. They all go together. Okay? So in these are two pictures of relations known as graphs, right? This is a relation. They're both relations. It's just a bunch of ordered pairs. They connect and make this picture. It's called a parabola. We'll worry about it later. And what they're asking for us to do is state the domain and the range of these two relations. What they're asking for, guys, is what x values do we use to make that picture? And in this picture, what are the y values? To do this, we use something called interval notation, okay? Which, please share with me after I go over it if you've learned it before, because if not, I might need to do a little bit of a review with you, or a lesson on it. So domain means the x values member, and range is your y values. Alphabetical order, D and R, X and Y. So looking at this picture, this can be confusing. Being able to look at a picture and tell me what are all the x values we use in that picture. Well, it doesn't mean what part of the x, remember this is the x-axis, this is the y-axis. It doesn't mean what part of the x-axis we're touching. It means if I asked you to sit here and name every single point, I would never do that. But if I said, what's this point? What's this point? What's this point? Forever on this whole graph going down, and those arrows mean forever going down. What are all the x values we use? So think about it. The behavior of this graph, as it's opening down, it's also getting what? Wider. So right here, this point is like 0, 0. So we use 0. We use 1, -1. We use 2, whatever, 3, 4. We use 104. It's way over here, but there is a point way, way down there forever that uses that. So what you need to know is that in this picture, we use all of the x values there are. The way we say all of them is from negative infinity. So I have a negative, I'm terrible at making infinity symbols. A negative infinity to positive infinity with parentheses around it. What that means is every single number on the x-axis would be used to make this graph. These arrows, understand, means they go down forever. So I can't put a number on the ends. It's not like from 4 to 5 or, -5 to 20 or something. It goes down forever. As it goes down, it goes left and right, so you use all of the values, okay? Forever in math is called infinity, okay? So to the left is negative infinity, and to the right is positive infinity. Okay, so we just named the domain. Have you guys seen this notation before, where my finger is? Have you guys seen that? Is that new for anyone? Raise your hand. Okay. And I am not forgetting about you. This is yours. And I'll make sure you get it. Let's talk about the range, okay? And I'm going to try and keep introducing this. Oh, let me show you another symbol. So another way of saying this is all real numbers. Okay, that's a lot to write, all real numbers. So we have a fun symbol. Watch, because if you blink, you'll miss it. There's a symbol that states all real numbers. That means this means this. So watch me do it. I make like 2 parallel lines just like this, and then make like an R, a capital R. Watch me do it like this. It's like putting an A and an R together. It's a math symbol that means all real numbers. It's kind of fun to make. It's easier than either of these, and that's totally fine too. So when I ask you what is the domain of this graph, you know it's from negative infinity to infinity, all real numbers, or this fun little symbol. Okay? One more time, just practice. 2 lines, and then like an R right through them. It doesn't have to be perfect. I'm not going to grade you on how beautiful your all real number symbol is. Oh, okay. Now let's talk about the range. Range is harder. Range is what Y values do we use? Now, the Y-axis has infinity too. It goes up forever and down forever. But look at this graph. Look at the behavior, we call it the behavior of this graph. It goes down forever still. It's just like this one. It goes down forever. Will this graph, do you think, turn around, like loop around and go back up? No. It's going to go down forever. That's what that means. So will we ever use any of these points up here? The answer is no. So you can't say it's all real numbers for the range. Look at the graph. What is the first Y value we use? What's this Y value right here? 0, 0. But all we care about is the Y value. So 0, okay? Because it could be 1, 0. It could be 2, 0. It doesn't matter. So here's the first one we use, and then it goes down forever. So because the maximum Y value is 0, that's the highest maximum, the highest Y value is 0, the range is Y, because range is your Y, is less than or equal to, what do you think? 0. That's it. Yeah. And I'll give you a little hint. Anytime you have this graph called a parabola, the domain, whether it's opening up or down, either way, it's always all real numbers. That's an easy one. The range is either going to be up or down from a certain number. Okay, and you'll see that again. All right? Let's go to the back. Now, yeah.
So I have some questions.
Okay.
It's okay that should I keep this book on?
You can, or I will hold it for you.
And the last question is that it's okay that if I don't read out those pages?
You and I will talk. Okay, you and I will talk about it later. Okay, that way we can figure it out. Okay. And just, is that the second page? Yes. Just so you know, I always upload these notes. Remember I showed you guys Canvas yesterday. So this video that I'm recording is me teaching. I always upload that to Canvas, and I will put these notes there and the homework key. So everything is always on Canvas. Okay, so let's look at this one. Look at this funny looking graph. We're going to find the domain and find the range of it. So let's look at it. Think about the X values this one uses. It's hard to see. Some people, it just clicks, just like anything else. Some people can look at that and just totally see what the answer is. Some of us are more literal, and it's hard to imagine that I'm not just talking about this little space. I'm talking about this graph forever. It's going down. What is it doing as it's going down? It's slight, but it is definitely getting wider, okay? It is getting wider, just like the graph before. There's a little loop-de-loop in the middle, but let me just give you an example. If I asked you what some of the points are, let's just talk about it. We use 0, 0. So 0 is one of our X values. Remember, domain is your X values. We use 1. There it is, right there. We use 2. We use 3. Like, here's 3. It doesn't have to touch at 3. It has to have an ordered pair where 3 is the X. And it is. Look, X is 3. So 1, 2. Here's 3 right here. 3 is part of the domain because you have to understand that arrow means it keeps going and going and going. So eventually, it's going to touch that graph there. So this is just like the parabola we saw. We will eventually use every number to the left of 0, called negative infinity, and every number to the right, which, as we just talked about, is all real numbers. All real numbers. You could also see it written like this, from negative infinity to infinity. They all mean the same thing. Okay, so domain was X, range, of course, is Y. Look at the graph. What's the highest or lowest? In this case, it's highest. You can't name the lowest Y value because it goes down forever. But we do have a maximum, a highest number we use on the Y-axis. What is it? What's the highest number that we're going to use in any ordered pair that is in the Y spot? I won't make fun of you if you mess it up. I just want to see if anybody knows. Is it 3? 1? That's exactly right. Y, who said that? Good job, good job. 3 is this line right here. Why did she say 3? Because that's the highest y value we use. It doesn't have to touch the y-axis. It has to be in an ordered pair. That's confusing, okay? So if you're like, I'm starting to get it, but it's still not clear, that's very normal, all right? So we start at 3. We don't go above it. There's no points above 3. We don't cross that line. 3 is the highest we go. And then we go where? Down forever. So which one of those would it be? That's right, A, less than. That is less than or equal to, in case you couldn't read it, don't remember. I know we have summer brain, a lot of times we do summer break, we forget everything, okay? Okay, so I am feeling like I'm gonna hold on this one. This is a different type of problem. I hate the order of this thing. We will switch probably mostly to make me doing my own notes because I don't like this, which I print for you and you fill in just like we're doing now. I have to do a lot of skipping around with theirs. I've been doing this so long, I know exactly what order I should do things in. So just hold, don't cross it out, we'll come back to that next week. I want to go right now to example 3. So I want to stick with what we're talking about, which is, so far we identified relation is just a set of ordered pairs, okay? It could be a graph, it could be a lot of different things. Then we talked about function. Is it a function if it has no repeat x values? That's what we're going to talk about here. And we also talked about domain and range. So those are the concepts I want to kind of cover today. So this is really the last thing we're going to do. So what this is asking us is determine whether each function is one-to-one. Now what that means is, I don't like how they looked at this. Yeah. If you must, yes. I don't like this. They don't do a horizontal line test. It's so annoying. Okay. Let's just talk about this then. I'm sorry, guys. I thought that we're doing something else. These 3 graphs, let's just ignore everything around them. I just want to talk about how to tell if they are a function or not. Remember I said it has no repeat x values? There's something called a horizontal line test. We should be able to look at a graph and say, yes, it's a function, or no, it's a function, just by looking at it, okay? And the way we do that is we use a vertical line test, okay? So if you look at this graph, unlock this. If I take my vertical line, pen, pencil, visual, whatever, and I just go from left to right across it, do I touch this graph more than once at any given time? So am I touching it one time? Yes. One time? Yes. One. This, yes, is a function because there's no repeat x values. That's how you tell, okay? Let me give you an example of a no, okay? Go to this little space here. I'm so sorry, I just do not like this book at all. Let me just put a circle on there. You guys just came off of geometry. Just sketch a graph of a circle. Anybody want to guess? Is this a function or not? No. Not a function. Why? Because pick a vertical line. Like if I just went right here, any vertical line. If at any point on this graph of a circle, I use the same x value twice, it's not a function. If you named these 2 points in an ordered pair, it would be negative, let's call it -1 something, -1 something. That's a repeat x value, not a function, okay? Is this one a function? Is g of x here, f of x, g of x, h of x? By the way, those just mean y. Let's get that out of the way. They are ways of naming a function, just giving them different names. So I can say to you, is f of x or g of x or h of x, instead of just saying the graph. I don't call you all boy, girl, whatever. You have names so we can differentiate between you guys. That's what those letters mean. Don't overthink it. Is g of x a function? Yes or no? How many say yes? How many say no? The yeses are right. That's a function. This is where you have to think outside of this box. As I take my pen left to right, I don't touch any of these points, any of the graph at the same time, more than once. As it goes down, it's not staying straight. It's not like a line. It doesn't go straight down. It's getting wider. So it's going to use a different x value every time. That's why the domain was all real numbers. So yes, this one is a function. I will tell you all parabolas are functions. Anytime you see a parabola like that that opens down or opens up, the answer is yes. You can just memorize it. Just like the domain is always all real numbers. What type of graph is this? What would you guys call that? Linear, line, it's a line, right? Is it a function? Oh, heck yeah. That's the king of all functions. That's where everything begins. Look, take your pen. As I go left to right, I never touch, there's no repeat x values. I use 0 one time. I use 1 time. Okay? So this is a function. All lines are functions except for one type. Let me show you. The only line that's not a function is a actual vertical line. Because you only use one x value with a vertical line. Whatever this x value is. Let's call it -2. See, you don't use any other. You use a bunch of y values, right? There's a ton of y value. You use every y value on the graph. But you only use one. So you're repeating the x's over and over and over again. That's not a function, okay? But any line that has a slope or even a horizontal line would be yes, okay? That's all we're going to talk about today, okay? Oftentimes, I'm going to have to pivot like that. You guys are my one and only class. So it's kind of like my first period pre-calc class. They're the first time I teach it in the day. The rest of the class thinks I'm an expert and I'm so put together. It's because I figured it all out with my first period. You guys are my only Algebra 2, which is going to make me so happy. I enjoy having that. But so I might change my mind in the middle of a lesson, which is always going to benefit you. I usually cut problems, not add on, okay? So now I'm going to have you just flip your book or your binder, whatever you're working out of right now, and you'll see pages labeled practice. This is actually page 11 and 12. You can see right here, I already picked out your problems. I'm about to change it because I just changed what I taught. So, and it's going to take a good couple of weeks for us to get really acclimated in how I do things. One thing I'm really wanting you to do is wherever your homework is, like right now it's here, I want you to label it. Today is called A1. Monday will be A2.